dsPIC33FJ06GS by Microchip. Welcome to the training module on dsPIC33FJ06GS. Today's training outline consists of CPU features and device specifications, application examples, CPU block diagram, high-speed analog comparator, ADC, UART, I2C, SPI block, and high-speed pulse width modulation module, application block diagrams. This CPU module has a 16-bit data-modified hardware architecture with an enhanced instruction set, including significant support for digital signal processor. The CPU has a 24-bit instruction word with a variable length opcode field. The program counter is 23 bits wide and addresses up to 4 megs by 24 bits of user program memory space. The digital signal processor engine features a high-speed 17-bit by 17-bit multiplier, a 40-bit ALU, two 40-bit saturating accumulators, and a 40-bit bidirectional barrel shifter. This device contains extensive digital signal processor functionality with a high-performance 16-bit microcontroller architecture. dsPIC33F switch mode power supplies devices feature several advanced peripherals, such as a high-resolution pulse width modulation, a high speed of up to 4 megasamples per second, 10-bit analog-to-digital converter, and a high-speed analog comparator module. Microchip delivers everything a power conversion design engineer needs: low-risk product development, lower total system cost, faster time to market, outstanding technical support, and dependable delivery and quality. These devices offer features supporting common multi-loop digital switch mode power supplies and other digital power conversion applications such as AC to DC converters, DC to DC converters, power factor correction, uninterruptible power supplies, inverters, embedded power supply controllers, circuit breakers, arc fault detection, and digital lighting. The dsPIC33F CPU has a 16-bit data-modified hardware architecture with an enhanced instruction set including significant support for digital signal processing. The CPU has a 24-bit instruction word with a variable length opcode field. The program counter is a 24 bits wide and addresses up to 4 megs by 24 bits of user program memory space. A single-cycle instruction prefetch mechanism helps maintain throughput and provides predictable execution. Each of the working registers can serve as a data, address, or address offset register. The 16th working register operates as a software stack pointer for interrupt and calls. The dsPIC33F switchboard power supply comparator module monitors current and voltage transients that may be too fast for the CPU and analog-to-digital converters to capture. The analog comparator provides high-speed operation with a typical delay of 20 nanoseconds. The comparator has a typical offset voltage of plus or minus 5 millivolts. The negative input of the comparator is always connected to the digital to analog circuit. The positive input of the comparator is connected to an analog multiplexer that selects the desired source pin. The high-speed 10-bit analog-to-digital converter module is designed to support power conversion applications when used with a high-speed pulse width modulation module. The analog-to-digital converter may have 1 or 2 successive approximation register modules, depending on the device variant. If 2 successive approximation registers are present on a device, 2 conversions can be processed at a time, yielding 4 megasamples per second. If only 1 successive approximation register is present on a device, only 1 conversion can be processed at a time, yielding 2 megasamples per second conversion rate. The high-speed 10-bit analog-to-digital converter produces two 10-bit conversion results in a 0.5 microsecond. The Universal Asynchronous Receiver Transmitter module is one of the serial input-output modules available in the dsPIC33FJ06GS101 and dsPIC33FJ16GS device families. The Universal Asynchronous Receiver Transmitter is a full duplex asynchronous system that can communicate with peripheral devices such as a personal computer, RS-232, and RS-485 interfaces. The module also supports a hardware flow control option with the UX-CTS and a URTS pin, and also includes an IRDA encoder and decoder. The internal integrated circuit module provides complete hardware support for both slave and multi-master modes of the internal integrated circuit serial communication standard with a 16-bit interface. The hardware fully implements all the master and slave functions of the internal integrated circuit standard and a fast mode specification, as well as a 7-bit and 10-bit addressing. The inter-integrated circuit module can operate either as a slave or a master on an inter-integrated circuit bus. The following types of inter-integrated circuit operations are supported. Inter-integrated circuit slave operation with a 7-bit addressing. Inter-integrated circuit slave operation with 10-bit addressing. Inter-integrated circuit master operation with 7-bit or 10-bit addressing. The Serial Peripheral Interface module is a synchronous serial interface useful for communicating with other peripheral or microcontroller devices. These peripheral devices can be serial EPROMs, shift registers, display drivers, and analog-to-digital converters. The Serial Peripheral Interface module is compatible with Serial Peripheral Interface and Serial Input-Output port from Motorola. The High-Speed Pulse Width Modulation module on the dsPIC33FJ06GS101 and the dsPIC33FJ16GS devices support a wide variety of pulse width modulation modes and output formats. This pulse width modulation module is ideal for power conversion applications. The pulse width modulation module contains 4 pulse width modulation regenerators. The module has up to 8 pulse width modulation output pins: PWM1H, PWM1L, PWM2H, PWM2L, PWM3H, PWM3L, PWM4H, and PWM4L. For complementary outputs, these 8 input-output pins are grouped into HL pairs. For centered aligned mode, the duty cycle, period phase, and dead time resolution will be 8 nanoseconds. Phase-shifted pulse width modulation describes the situation where each pulse width modulation generator provides outputs, but the phase relationship between the generator outputs is specific and changeable. The dsPIC33FJ06GS101 and dsPIC33FJ16GS architecture features separate program and data memory spaces and buses. The architecture also allows the direct access to program memory from the data space during code execution. The space is addressable by a 24-bit value derived either from a 23-bit program counter during program execution or from the table operation or data space remapping. User application access to the program memory space is restricted to the lower half of the address range. Microchip 16-bit dsPIC DSCs provide on-chip peripherals specifically designed for high-performance, intelligent power supplies. The DSP engine can perform a single-cycle MAC with data saturation, zero overhead looping, and barrel shifting required to support fast control loop execution. These devices include peripherals specifically designed for power conversion. Peripherals such as high-speed pulse width modulation, analog-to-digital converters, and analog comparators can be tied together using an internal configurable control fabric that enables them to interact directly with one another, resulting in stunning performance gains in digital power applications. Traditional power supply designs use analog ICs with fixed functionality to provide regulated power. The intelligent power supply integrates a microcontroller or a digital signal controller for a fully programmable and flexible solution. Intelligent power conversions lower the system component count. These devices are enabled by the ability to perform the power conversion control via reprogrammable software and the performance and features of microcontroller and digital signal controller solutions for microchip. The dsPIC33FJ DSC family and power-efficient and highly integrated DC-to-DC converters dynamically controls different power stages. High-speed analog-to-digital converters, pulse width modulations, and comparators work together without using much CPU bandwidth. Faster digital control loops and compensators can be executed using a high-performance DSP engine. Advanced features such as dynamic load response, protection, sequencing, remote control, and communications can also be implemented. Power factor correction is essential in higher wattage power supplies to reduce harmonic content, system losses, and radiated emissions. The dsPIC DSC simplifies the implementation of a boost power factor correction algorithm using average current mode control. The pulse width modulation command is calculated digitally by computing the product of rectified input voltage, the output of the voltage error compensator, and the output voltage feed-forward compensator.